Hello class, we are going to talk about writing equations of parallel and perpendicular lines. So the slope of parallel lines are the same. They have same slope. Okay, so note parallel, the double L's in between the R and, or between the A and the E, they do give me parallel lines. They are the same slope. Sometimes you'll see me use this, meaning parallel lines, as the symbol. Now the slope of perpendicular lines is the opposite reciprocal. So this means we're going to change the sign. So the change sign and a flipped fraction. And note, in order for it to be perpendicular, it has to have both. Okay, so now we have horizontal and vertical lines. Now horizontal lines, remember they have the abbreviation HOI, and remember their slope is 0. Okay, so that's what that means. Vertical lines, the abbreviation VUX, has a slope that's undefined. So note, horizontal lines are parallel to each other and vertical lines are parallel to each other, but horizontal and vertical lines are perpendicular. So we can say H is perpendicular, that's the symbol for perpendicular, to vertical lines. So undefined and 0, those are perpendicular slopes to each other. Okay, so keep that in mind for something that you'll see definitely in your future. So our first example is determine which of the lines are parallel. So we have 3 lines. We have A, B, and C. So let's find the slope of each line, and then we're going to compare whether they're parallel or perpendicular to each other. And so let's find the slope of line A. So I rise up 1, okay, and then I run 1, 2, 3, 4, and 5. So the slope of line A is I rise up 1 and I ran 5. So that's of line A. Now let's do the same thing for B. So B, I rose 1 and then I ran 1, 2, 3, 4. Okay, so there's that. Okay, and note, I forgot that this is a negative. So for B, I rose up 1, did 1, and then I went to the left 4. So I have negative 1 over 4 because they are decreasing. And then our last one is C, so I'm going to rise up 1, and then I'm running 1, 2, 3, 4, and 5. Okay, so C, the slope is rising up 1 and I run 5, and it is decreasing, so it is negative. So now I have to tell which ones are perpendicular or parallel to each other. And remember, parallel lines have the same slope. So I need to make sure which ones have the same slope. Well, only 2 of them have the same slope. So A has the same slope and C has the same slope. So we would say A is parallel to C because they have the same slope. Okay, you can also say A is parallel to C. Okay, that's another name to say parallel. So example 2, it says determine which of the lines, if any, are parallel or perpendicular. So the one thing we want to do for all of these is to make sure they are in slope-intercept form, which is y equals mx plus b. That way we can identify our slope. Okay, so we want them to look like this so we can identify our slope. So the first one is already done for us. It's already in y equals mx plus b. It's already in slope-intercept form, and to identify our slope, we know that it is 4. Okay. Now for line B, it's in standard form. So if it's in standard form, I need to solve for y, and to make sure it's in slope-intercept form. So when I have x plus 4y equal to 3, I'm going to subtract x from both sides. So then I have 4y is equal to negative x plus 3, and then I'm going to divide each term by 4. So now I have y is equal to negative 1 over 4x plus 3 over 4. And identifying our slope is negative 1 over 4. Okay, now our last one is line C. So line C is also in standard form, and so we need to make sure we solve for y for this one as well. So we're going to solve for y. So with negative 8y minus 2x equal to 16, so now I'm going to subtract 2x from both sides, or add 2x to both sides. So I'm going to add 2x. So now I have negative 8y equal to 2x plus 16. Then I'm going to divide. Apologize for that. So now I have to solve for y. And so I have negative 8y minus 2x equal to 16. I need to get x to the other side, so I'm going to add both sides with 2x. And then I have negative 8y equal to 2x plus 16. So now I'm going to divide each term by negative 8. So I have y is equal to 2 over negative 8 does give me a negative 1/4 if I'm reducing x, and then 16 divided by 8 is 2, or negative 2. Okay, and the slope here is negative 1 over 4. So now I've identified the slope of each term, and so now I need to know which ones are parallel and which ones are perpendicular. And so let's see. So we have parallel is same slope. So which ones are parallel to each other? That would be line B and line C. So we can say line C is parallel to line B because they are the same slopes. That was parallel. Now we need to look at what's perpendicular. So remember, perpendicular means taking the opposite reciprocal. So let's say we want the opposite reciprocal of this slope. I know that 4 as a fraction is 4 over 1. And then when I take the opposite of it, that means I'm going to change the sign, which means this makes this a negative 4 over 1. And then the reciprocal part means I'm going to flip it, which makes it negative 1 over 4. So do any of these have a negative 1 over 4? They do. Line B and C are negative 1 over 4, which means that line A is perpendicular to B and line A is perpendicular to C. So we'd say line A is perpendicular, so symbol for perpendicular, to line B. And then we also have line A is perpendicular to line C. Okay, so those we can tell are what's parallel and what's perpendicular. Now we're going to go on to example 3. Feel free to pause at any time if I'm going too fast. So example 3 says, write an equation of the line that passes through 5, negative 4, and is parallel to the line y equals 2x plus 3. So our first step is to find the slope of the parallel line. So we know the slope here is 2, and remember, parallel means the same slope. So our new slope, or say parallel M, is going to be 2 as well. Okay, so then we're going to use the slope and the given point to write an equation. So what form gives a slope and a given point? Well, that would be point slope form. So we're going to use point slope form. And remember, point slope form is y minus y1 equal to m parentheses x minus x1. And remember, with that one, we need to make sure we flip our points inside x1 and y1. And so when we're rewriting this, we have y, our point is 5, negative 4. So opposite of negative 4 is a positive 4, equal to our new slope, which is 2, and then parentheses, x, and then we have a positive 5, we're going to make it a negative 5, so x minus 5. So there's point slope form. Say we want it in slope intercept form. Then all we have to do is distribute. So here's point slope. Now we're going to put it in slope intercept form. So I'm going to distribute my 2, so I have y plus 4 equal to 2x minus 10. And then I'm going to subtract 4 from both sides. So then I'm left with y equals 2x minus 14. And there's our slope intercept form. So now I've written it in 2 forms. Why not go ahead and go into standard form? Now we have all forms to make our equation. So now remember, standard form is ax plus by equal to c. So remember, that means we need to move 2x to the other side. So I'm going to subtract 2x. So now I have negative 2x plus y equal to negative 14. But we don't want a negative a, so we're going to multiply each term by negative 1, which changes our sign to 2x minus y equal to a positive 14. And there is our standard form. So now we've written it not just in one form, we did all 3. Normally it will tell you which form they will want you to have it in, but in this case, for extra practice, we put it in all 3 forms. So we did point slope form, and then we converted to slope intercept form, and then we have standard. And these equations are going to be parallel to our given equation here of slope intercept form. Okay? So note they have the same slope, but different y-intercepts. So now we're going to go on to example 4, where it talks about perpendicular lines. So it says, write an equation of a line that passes through negative 3, 1 and is perpendicular to the line y equals negative 1/2 x plus 3. So now we're talking about perpendicular lines. Remember, perpendicular is the opposite reciprocal. So we know the original slope here, m, is equal to negative 1/2. So if I have the original is negative 1/2, I want the opposite reciprocal. So opposite meaning we're changing the sign. So if it's negative, it's now positive. And then we're going to take the reciprocal, which means to flip it. So there'll be 2/1, but 2/1 is the same as 2. So our perpendicular slope is 2 now. So when we're plugging in m for our new equation, we're going to plug in 2. We're not going to plug in negative 1/2. So now it says use the slope and point to write the equation. And so just like we did before, we're going to use point slope form. And point slope form is written there, so we're going to use the same thing with our new point, negative 3, 1. So I have y minus 1 is equal to our new slope, which is 2, and then parentheses x plus 3, because we're taking the opposite of x1. So there's point slope form. Now, if I wanted in slope intercept form, I'm going to distribute. So then I have y minus 1 equal to 2x plus 6. So that's after we distribute to both terms, and I'm going to add 1 to both sides. So y equals 2x plus 7. Okay, so there is our slope intercept form. And for extra practice, let's go ahead and put it in standard form. So when we have y equals 2x plus 7, remember standard form is ax plus by equal to c. So I'm going to make sure I have x and y on the same side. Subtracting 2x, so I have negative 2x plus y equal to 7. Now we don't want a to be a negative, so we're going to multiply everything by negative 1, which changes every single sign. So now I have 2x minus y equal to a negative 7. And that is our standard form. So now we've done it in all three forms with the given equation that's perpendicular to the original. So there's our point slope, and there's our slope intercept, and our standard. So now we're going to our last example, which is a word problem. It says, the position of a helicopter search and rescue crew is shown in the graph. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents this path. So we have the water and the helicopter, and then we have the shoreline. These two lines are supposed to be perpendicular to each other. So we're going to pick 2 points in order to find the slope of the path of the helicopter. So let's find the slope of the helicopter. So let's choose this point and this point. And again, we're going to use rise over run. So I rise 1, 2, 3, and then I run 1, 2. And our slope is a positive rise 3 and a run 2. So slope there for the helicopter path is 3 over 2. Okay, so then for the helicopter, we have m equals 3 over 2. So now, what about the shoreline? So I'm sure we can pick 2 points here, and let's pick this point, and we have this point. So let's find the slope of the shoreline. So the slope of the shoreline is where I rise 2, and then I run 1, 2, 3. So I have 2 over 3, but my line is decreasing, so it's a negative 2 over 3. And so these two lines are perpendicular to each other. However, it's asking for an equation. So let's put it in point slope form. And so I have my new perpendicular slope, and let's pick a point. And I'm going to pick the point 4, 1. I'm going to pick the point 4, 1. 4, 1. So I have y minus 1 equal to negative 2 over 3 parentheses x minus 4. Okay, so I've given an equation that represents the path of the shoreline, and then let's do the same thing for the water line. So let's do the water or the helicopter and that path, and so we know that it's 2 over 3, but let's pick a new point, and let's pick that point to be 12, 1. So 12, 1 is right here that we picked. So we do y plus or minus 1 equal to parentheses, or 2 over 3 is our slope. Sorry, 3 over 2 is our slope. 3 over 2 was the shoreline. Then we have x minus 12. So now we've given both equations for the helicopter's path and of the shoreline. And so that's the way how you can tell from a graph to find perpendicular slope. And that concludes our notes for parallel and perpendicular lines. I apologize for any interruptions throughout this video, but if you will have any questions, please feel free to email me or message me on Remind. I also have tutorial hours Wednesday morning 6:45 to 7:15, as well as Thursdays after school from 3 to 5. Thank you so much.